So hello again. Tonight we're going to be talking about another in our series of solving problems. Tonight we're going to be talking about transportation. So as I mentioned, this is another one of our series. We had talked about power and propulsion and communications, and now we talk about how we get from one point to another, and how do we get rid of some of the problems associated with it. And yeah, I do try and go out there and see if I can find people who actually understand all this stuff and make references to them. A lot of this is repurposing and connecting dots, not yet at the commercial scale, so you can't go off the shelf and buy yourself this stuff, but just where things might get to. But if you start with the premise that it's impossible or counters the known laws of physics, there's stuff out there that people are doing. There's research projects. Some of them are black budget projects. Some of them are not black budget projects. They're just very heavily invested projects. So some of this stuff might come to pass as we've spent billions on other things like fusion power, particle physics, and quantum computing. If we spent literally just more millions on this stuff, we might find we can solve these problems. So as I said, in this episode, we'll talk about transportation. So here's the simple one. All transportation has the same problems. To get from A to Z presumes you travel through B to Y. You can't just jump from A to Z. Even with a plane, you've got to fly over the distance between the 2 points. Paths from A to Z typically share paths with others. So whether I'm going from A or A prime to Z or Z prime, I might share the path from B to Y. Doesn't matter what type of transportation conveyance you use, cars, trucks, buses, trains, trams, subways, all kinds of airplanes, private or commercial, boats, ships, freighters, private, commercial, even submarines go through the same problem. There's a limited amount of space, physical space, to allocate for shared transportation paths. There's your local streets, there's the arterial roads to get you to the higher density highways, and then there's the expressways. For railroad, there's the same sorts of things. There's the slow boat line and the express line. For airports, same things. There's the stopover flights and the nonstop flights, and you can only fly certain places because things like mountains get in the way, and you don't want to be too far from an airport. You have problems. So the shared paths are known as air corridors, and you can't go everywhere because sometimes there are areas you can't fly over, like military, industrial complexes that they don't want planes flying overhead. And even for shipping, you have harbors. You can't, bring a big boat anywhere you want. Where they need to be worked on, you have ports and shipyards. And then same sort of thing. The ships don't just go anywhere they want to go. They travel on recognized sea lanes, which are shared by other things. So as the transportation demand increases, congestion on allocated paths and shared paths increases as that's what's available. You can't drive your car anywhere you want to. Maybe if you go out to the Everglades, you might drive your off-road four-wheeler wherever you want until you get stuck or run into a tree. But there are things that get in the way of wanting to go wherever you want to go. So we typically ignore all but the waypoints. If you're going a long distance, to avoid getting mentally overloaded or even bored, we forget about all the stuff in between. So if you're on a long trip from, let's say, Fort Lauderdale to Atlanta, Georgia, and you're going to go up the turnpike, and then you're going to go on I-75, and you forget all those little exit ramps that you pass. You forget all the way stops where you don't need gasoline, you don't need bathroom, you don't need a restaurant, you just drive right past them. You forget all those stops, because otherwise, if you stop to make note of every one of them, you'd get mentally overloaded or bored. You'd go, man, this is a long way to Georgia. So we ignore all the waypoints. And when you're flying, even more so, you just fly over them. You never even notice they're there. But, we use the waypoints as convenience. Charge your EV, refuel the vehicle, eat or drink, stop off at some tourist stop to buy something, to explore something, the world's biggest ball of yarn kind of stuff. Or a member on the trip needs a restroom right now. I don't care if it's not a restaurant, just pull off at the nearest fast food restaurant. Or it's like, I'm driving by myself. I've been driving for 2 hours. I need to take a break. So in train travel, it's the same sort of thing. You have express trains, and then you have the milk run, and you get bored on the milk run because it's stop after stop after stop, and you forget to get off where you should get off, and you're 2 stops past your destination because who's going to wake you up? If you didn't hear the last 5 exit calls on the PA system, you're not going to hear yours. And in air travel, people don't like the layovers. They're too long. They're inconvenient. You got to walk between gates. Sometimes if it's international, you have to reclaim your luggage and check it again. It's like, those intervening points are a pain. So we try and combine them so we stop less often. We'll bring food and drink with us to avoid having to stop for expensive food along the way. Buses, trains, planes, and RVs include restrooms so that you can change drivers as shifts and, use the bathroom on board and keep going. Imagine how often a plane would have to stop if, 200 people all decided one of them had to go to the bathroom. So we ignore all the points along the way, which is why we don't remember they exist. We forget all of them. But if a path becomes too congested and you have to literally stop on the highway, you're in California on the 405, you remember painfully every one of those exit ramps you're not taking because you're sitting there for 5 minutes staring at the exit sign. So speaking of the 405, here's how we improve congestion. Add more lanes, add dedicated express lanes, add more lanes to the on-ramps or off-ramps, add traffic lights at the on-ramps to, gate the flow of people coming on board. Or in New York City, I like this one, increase the number of decks of lanes. This is where topology goes 3D. Dedicate travel directions in Chicago and on 595. The lanes only go a certain direction at a certain time of day to get even more lanes wider. For trains, they run trains during rush hour more often than during off-peak. They'll add dedicated express trains. They'll add longer trains. Brightline trains only have 3 cars in them. They have a high-priced car and 2 budget cars, and then an engine on each end, so they don't have to waste time turning around. But you want to fly more often, you can fly more people. You can add more flights, fly at different altitudes. The express flight goes higher and over the milk run cities. If it's shipping, you widen the channels, add more sea lanes. Think about submarines. If they're on maneuvers and you've got some industrial stuff that needs to be done that's not secret military warfare, they may be at different depths because cheaper diesel submarines can't go as deep as the nuclear ones. So for lengthy travel times, you could even consider increasing the speed, increasing the velocity of the vehicles. In highways, for a while we had 70-mile-an-hour roads, and then it became 55, and everybody hated that because it was just too slow. Your brain could actually comprehend what was going on as you drove down the road, and it made it look like it was taking longer than it really was. So let's get the speeds back up to 65. I always thought there ought to be statistics you can look at, as in, okay, when we were doing 70, what was the accident occurrence per traveled mile vehicles. And then we went down to 55. I'm guessing it ticked up slightly because people were bored and didn't pay attention and had more accidents. So when we brought it back up to 65, the accident rate went down a touch. That's just my opinion. But I've done computer simulations of traffic movements and said, hey, now some places out in the open western parts of the US, speed limits are 80 miles an hour because it's miles and miles of nothing but miles and miles. So to keep people's attention, go faster. To make it go faster, you can have the slow boat lanes doing 55 and the express lanes doing 65 or 70. You can do what Brightline did, get rid of all the joints in the tracks and weld and then smooth finish all the rails so there's no clickety-clackety, and you can do 110 miles an hour instead of 90 or 120 if you're going up to Orlando. You can create dedicated train systems that go even faster, a maglev, or putting it inside of a vacuum. You can create aircraft that are going faster. You know, there's still that need for speed. Let's have a commercial supersonic transport for the people that don't mind spending a lot more money and just want to get there much faster. But hey, NASA, go make the sonic booms go away. So NASA's working with the plane builders to build planes that they've referred to it as the boom will be gone. It'll just go thump. That's still a boom. It's just a less high amplitude boom. We create seagoing vessels that are hydrofoils or, you know, big bada boomba engines on the back so you can go faster. When I was in California on a tourist trip out to Catalina Island, we got to take the hydrofoil out to the island. We got there in 35 minutes, which was like half the time of the regular boat. The problem was the hydrofoil, if you were in the front of it, it would bounce you up and down to death. So you had to sit in the back of the hydrofoil. But the normal deep hull boat took a lot longer, but because they had stabilizers, the ride was much smoother. So we took the regular boat on the way back, and it took almost 90 minutes on the way back, but it was a lot more comfortable ride. Or you can have express routes where you reduce the number of intervening stops for all forms of transportation. So ceilings. At what point do you realize this is the Achilles heel of this mode of transportation, and we just can't take it any further? Well, if you think of roads, demolishing homes and businesses to create more right-of-way for lanes of roads or tracks of railroads, cutting wider paths through mountains, be it, you know, cutting off mountaintops or creating tunnels. And when you want to go over a mountain peak, as you can see out in places like California and Hawaii, you run them along the mountain edge or the shoreline, and I'm sorry, there's just no more room for another lane. And the lanes that are there don't last long. They fall off the edge of the cliff. So yeah, you can take it just so far. Without allocating more tracks, you can only run so many trains at a time in a particular direction. So when Tri-Rail first started in Southeast Florida, they only had one track. And you had to wait for a freight train before your Tri-Rail train could make its path north or south. That's actually counter to the laws of rail movement. Higher speed trains are supposed to have right-of-way because they're shorter and they can literally get through and not block the tracks as quick. But in Florida, they turned it the other way around to give privilege to the revenue bearing of the freight hauling. So Tri-Rail said, okay, Florida, we're going to spend the money, we're going to raise the rates a little bit, and we're going to double track everything. And they double tracked it. And in fact, crossing New River, Tri-Rail actually has no bridge, no adjustable span, no opening span. The freight trains, because of their weight, still has a railroad bridge, a bascule bridge that comes up and down. But Tri-Rail there's no opening. It just goes over a very high arced bridge. Well, the same thing holds true for Brightline. Brightline, when they said, we want more volume, we want to be able to do the freight, we don't want to be blocked by it, and we want to go higher speed. So they improved all the track. So you're now going to have freight that can move faster and have dedicated freight, and also Brightline moving north and south 90 miles an hour through southeast Florida, or down to 20 miles an hour through some spaces that are really congested. But 90 miles an hour as it opens up into Broward and Palm Beach County, and then 110 miles an hour when you get north of Palm Beach County. And then as you go across over to Orlando, where there's dedicated track and no railroad crossings for cars to worry about, or pedestrian crossings, they'll do 120. I can remember being over in the UK and riding on the Intercity 125. It literally did 125 miles an hour, and that was back in the 80s. So trains can go faster. So if you make your freight train even longer to carry more freight, well, you have longer wait times, but you also have longer crossing times at railroad crossings. How long are you going to wait for that freight train to go by? That's where you get people driving around stuff. Not good. Increasing flight paths and number of planes at different altitudes increases collision safety risk. Adding more sea lanes might not be possible because big ships need deep water for their deep hulls. So, when you come into Port Everglades, the channel's only so wide. Submarines can only go so deep, and you can't get them too close to shore because it gets shallow. And for lengthy travel times, you can increase the velocity. You can only reserve so many lanes before it just irritates others and has the same problem. Trains are aerodynamically limited, even in a partial vacuum. About 300 miles an hour is the fastest maglevs they've got in China at the moment. Supersonic, what do you do after supersonic if that's not fast enough? Hypersonic, well, there's a thermal limit you run into. The air molecules are still there even at higher altitudes, and you have friction on the front of your aircraft wings and fuselage, and you don't want it to melt off. So you can only go so fast in air. Seagoing vessels are ultimately limited by water and the wind that opposes them. I was reading something today that they were talking about the jet streams. If you want to go from west to east, you have a tailwind. If you want to go east to west, you have wind in your face, courtesy of the jet streams. So if you think you're going to do 500 miles an hour from Florida to the UK, you can. If you think you're going to do 500 miles an hour coming back the other way, nah, more like 400. Okay, and when does it get to the theater of the absurd? The picture at the bottom is actually an egress toll booth area in California. I don't even want to count the number of lanes, but you can see on the left and right edges in the upper corners, that is how many lanes there are, and all lanes are in motion. There's no blocked off area. That's how many cars they were getting to come off the expressway and go to local artery roads. So in California, New York, and DC, they have as many lanes that is physically possible, including timed on-ramps. But what do you do after that? They're already talking about mountain paths in Hawaii and California where they're running out of space to make them. It just becomes cost prohibitive. Longer trains take longer time to load and unload. I don't know if you've seen the videos of subways in Japan where they're literally having police pack people onto trains like sardines so that the trains only have a limited amount of time in the stations. You want to put that many people on a train, if you want to let everybody just sort of mingle on board at their own rate, you're going to take longer to get people on the train than it takes to get people off the train at the next stop. Longer freight trains take an absurd amount of time to load and unload. imagine the bottlenecks at the California freight yards. They can unload the ships, but now it's got to get on trucks and trains. You can have more flights per hour, but imagine what happens if you have a computer failure like, oh, I don't know, Southwest Airlines, or you have weather cancellations. If you have rain in Southeast Florida, it can actually ripple up all the way to the Northeast by planes not leaving in the afternoon. The same thing holds true the other way. If you just have a hint of snow in Chicago, the weather can be glorious in South Florida. They will not let you leave because they don't want you stacked up and running out of fuel over Chicago, or worse yet, having to land at some other smaller airport where they're not prepared for that many flights. I like this one. You might have remembered they widened the Panama Canal to something called Panamax. There is now an effort underway to create another carved through the mountains channel that will be wider than Panamax, because you just can't get enough containers on those freighters. So imagine the absurdity of Southern California seaports if now they can have, 25% wider than Panamax coming in and going out. It just becomes absurd. You can make things go faster, but eventually, you got to get on and off the highway, and you're not going to do that at 80 miles an hour. You got to drop the speed. The moment you drop the speed, you've got congestion. Getting on, getting off. The bored vacuum tunnel trains, not here yet. The loop system in Las Vegas is actually Tesla vehicles driven by people as little chauffeured vehicles. And they're looking to expand that to 25 additional stops because the street level traffic in Las Vegas is horrible because you've got so many pedestrians just ignoring the traffic lights and hundreds of people just walking across the street en masse. It's like the spring vacationers in Fort Lauderdale on Fort Lauderdale Beach. You get 200 people that decide, I don't care what the walk light says, we're going now. And the traffic just has to stop. So you can have congestion at the people level that stops cars, which increases the car congestion. If you've ever taken a cruise ship out of Fort Lauderdale or Miami, and you realize it takes 5 hours to board and it takes 3 hours to disembark, it's because of luggage. Literally, when you get 5,000 passengers on a boat, and then you say every one of them has at least 2 pieces of carry-on luggage, that's 10,000 pieces of luggage you have to load onto the ship and then deliver to the staterooms and then gather up from the staterooms and then get off the ship when you arrive. It just becomes absurd. Of course, the same thing's true of aircraft carriers. Naval aircraft carriers at one point had over 5,000 crewmen on board. And they've literally reduced the number of crewmen down to 3,000, and they think they're doing a good job. 3,000 crewmen on board a single ship. The ship gets bigger because they want to launch and land more planes, and that requires more supplies. Literally, when they went from hydraulic steam-driven catapults to electromagnetic, essentially railgun-based catapults, they increased the uptime, the reliability, and reduced the number of people required to maintain the catapults. You don't need a hydraulics engineer if it's electrical, because you already got an electrical guy. So, you don't need 5,000, you need 3,000. So there are ways to improve this stuff, but what's that old saying? When your hemorrhoid is this big, making it this big is no solution. So let's describe the points in space. You want to get from A to Z, and you don't want to have to go through B to Y, particularly if it's shared. Here's where the stretches come in. So to solve the problem, the first thing you have to do is define your 2 points. Well, people say, I'm at my house and I want to get to some people I know up in Jacksonville. Okay. What about all those points in the meantime? I have to think about all that stuff? Yep. Well, what about where you're leaving from and where you're going to? What if you're going to Colorado? You're going to go to Denver, the Mile High City. You're going to have to not only think in 2 dimensions, you're going to have to think in 3 dimensions. It really gets me a lot to think about. What about the angular relationship? What direction are you going between your 2 points? And how do you describe that? Well, I've got latitude and longitude. Well, that's because you're on the Earth and you have a GPS system with geodesic coordinates. What if you're doing spacecraft? What if you're going between 2 points in space? You need a reference point, an agreed reference point. And now it's the angles going between the 2 points. Like, oh, my head starts to hurt. If you want to describe 2 points in space, you need to fully describe them. So what about other things besides just the locations? Like I said, all those vectors going from the different points. What about the ambient conditions at the 2 sites? Air is going to be different. What if you're going from Earth to space? That's a vacuum. Air at different altitudes, you need airlocks. What if you're going from, someplace to an underground cave? Now it's subsurface. What if you're going from above sea level to below sea level? Now you got liquids to deal with. What about gravity? When you change altitude on Earth, gravity changes. And it changes enough to actually affect atomic clocks, which are particle fountains. So the gravity makes the particles move faster and slower because the gravitational constant of the universe didn't change, but your distance from the gravitational source changed. And what about gravity that bends things in space, bends space-time, and you want to fly near something like, I don't know, a moon or a planet or a star? You got to figure in the curvatures. You need to fully specify a point in space-time and the other point you want to get to, and then all the stuff you might travel to between the 2. So there's disciplines within astronomy and astrophysics where you talk about astronavigation. So you have astronavigators that, if you remember the movie The Martian, they actually had a guy who figured out how to get them back based upon what he knew about the spacecraft and where Mars was and the rocket that was left on Mars. And he figured all the astrodynamics of that stuff. So that stuff actually exists, and you have to think about it. Everything in space is moving. So when you have your 2 points in space and you say, I know where I'm at and I know where I want to go, the points could be moving independent of one another. So if you want to get from the Earth to the moon, oh, by the way, the Earth is rotating and the moon is orbiting the Earth. So if you're not moving when you move, then you could wind up where the moon was, not where the moon is. So things are always moving, and it gets to be like very high velocities on very large things. So the Earth is going around the sun at 70,000+ miles an hour. So if I said, I want to get from Earth to Mars, I have to take into account the Earth going around the sun and Mars going around the sun, and how the relative velocities of those 2 things exist, and the fact that the orbits are not perfect circles, they're slightly elliptical. So if I want to get from here directly to there, I got to figure all that stuff out. But let's say I want to go from the Milky Way to Andromeda. Now I've got to take into account the fact that these 2 things, they're actually rotating around a galactic cluster, and they're moving towards each other. So you think your head hurts from just moving on Earth. Imagine moving in the 3 dimensions of physical space. Okay, now we take it to the next level. What about the 4th dimension? Time. Well, you have to take time into account because space, time, and velocity and acceleration tell you all that stuff about how things are moving. Well, if you happen to get close to something that has more gravity, whatever vector you're using to determine your acceleration, that's going to change. So, as I like to put it, if you want to move in space, you have to also consider traveling in time. And if you want to move in time, you have to also consider that things travel in space. So if you want to create something that can travel in space-time, you have to think about both of them at the same time. And as we have faster and faster things, we're already doing that. We have to take into account that GPS satellites are orbiting the Earth at around 18,000 miles an hour. And that becomes relativistic on the radio transmissions to the Earth from the GPS satellites. So your atomic clock time signaling has to stretch a little bit. So you got to take all that stuff into account. Okay, let's get to the point here. How do you do it? How do you go from A to Z without going B through Y? Okay, we already know that if you have a high mass, it bends space-time. So what we need is the ability to bend space-time under computer control. Sounds simple, doesn't it? But right now we only have that singularities, black holes, neutron stars. We know about all that stuff bending space-time rather considerably. But we don't need to bend things past the event horizon. We just need, small amounts of movement. We've discovered that the once theoretical Higgs boson might be a force carrier for mass. We haven't said it's a graviton. It's not a gravity particle or gravity wave, but we do observe gravity waves. So, as the saying goes, put a push pin in that and keep an eye on it. If we can ever find a way to create Higgs bosons on the fly when we want to, at the density, at the flux that we want it, we might actually create the ability to have localized changes in space-time under computer control, obviously, because CERN's colliders run by computers. So if we can do that on a local basis, we don't need singularities or all the energy in the universe to do warp drive. We just need something local. And if we can do other things with other subatomic particles, like we regularly move electrons around and we spit out electrons and consume electrons, and we do the same thing with photons. You want a flashlight, you're basically applying energy to create photons under your control. So we already have the ability to do that. Particle colliders, well, we spit out, we ionize atoms to create streams of protons. So we're already into particle physics in a big way to do it under our bidding. We just need to find what particle is associated with mass and then have it do the same thing. Yeah, I've got a leap here. I've got, we don't know how to do it yet. But how many decades ago was it we said, yeah, we think these things exist called protons. And then we built bombs around them and cyclotrons. And now we spew out streams of protons like it's nothing. And we spend billions of dollars building colliders like CERN. So we just have to spend the money. We figured out how to spend money to do all sorts of stuff. We just need to find a way to say, okay, the goal is to find a way to create mass under computer control. So we need a particle or a wave that we can synthetically spew at our discretion. So that's how you do it. You create mass under whatever density you want, whenever you want it, and therefore you bend space-time on a localized control basis. So once you can do that, you can actually, at a very dramatic level over a very small amount of space, take A and grommet couple it, so to speak, with Z. And now you have the ability to just maybe step across your portal. So imagine if you could deliver packages that way. And let's say you just did it like from Amazon warehouse to Amazon warehouse. Nobody needs to be the wiser. But if you could do that, then things like cars and trucks and trains for freight, you don't really need that stuff anymore. Let's just identify this ability to create mass and shape it on a localized basis to join 2 points in space-time as spatial transportation. Just give it that. I'm sure somebody will come up with a commercial buzzword for it, but I'm just saying it's space and we're transporting stuff. So it's spatial transportation, but it's not space transportation because it doesn't necessarily need to be in the vacuum of space. It can be from anywhere to anywhere. But what is this not? Strange as it sounds, this is not an Einstein-Rosen bridge because distance between the two endpoints is 0. There's no bridge time. There's no tunnel that you transfer. It's not quantum teleportation. That sounds really good, but have you seen them doing that with anything larger than, a couple of entangled particles? They're not moving matter yet. This is not a jump gate or a jump point where you might have to transition through multiple to get to your destination. This is A directly to Z. This is not wormhole tunneling like you'd see on Stargate or something. There's no like zipping along through the tunnel. This is like done. If you've watched other TV science fiction, a slipstream drive, as they've had on Doctor Who, whatever that is. This is not a warp speed. The Albuquerque drive, whatever that turns out to be, no matter how much they've reduced the amount of energy, it no longer takes the total amount of energy in our galaxy. It just takes, 1% of it. That's just still, I'm sure that's way too much energy. And there's no spaceship required. If you can open up a portal, then you just take the package in the cardboard box and shove it across, and then close the portal. So don't need a spaceship. We're not talking about transporters because we're not decomposing matter and then reassembling it. So the Heisenberg uncertainty principle of you can never know where something is or where it or how fast it's moving, because to do so destroys the particle. So no Heisenberg uncertainty principle. And we're not destroying matter or energy in the process. So the conservation of momentum and energy is also safe. This is not violating that. We're just simply folding space-time. And we're not doing it, on a large scale, like bending light by the mass of the sun, as, Einstein predicted that, the light from stars can be bent by bent by the sun and only observed during a total solar eclipse. And it's not, dune-style space folder vessels, and we don't need the alien navigators consuming spice in order to fold space, and they don't just like disappear and reappear. This is like, snap, you're there. So I did find an analogy as to what this might look like. So if you've watched Marvel's Doctor Strange or the other movies in which they exist, and like She-Hulk and such, you'll encounter this technology called a sling ring, which they jokingly refer to as a slingy. It's obviously a TV movie special effect, but they open a portal using the sling ring, and then they just sort of step across. And they don't worry about things like atmospheric pressure differences, and you got to worry about movement and space-time differences. They just sort of like, it's movie magic. You go, the portal opens up and you can just step across. That's the closest thing to it. Although you don't need the like slinging on your finger and swirling and using your mind to control it, and you don't need the flaming ring, the fiery ring around it. That sounds a bit dangerous. It's probably just a cloud app that you say, I'm here because you know where I'm at. I want to go there. I need a portal. Kind of like the Uber app, or what's the other one? Uber and
Lyft.
Yeah, it's kind of like Uber and Lyft. You just tell it where you want to go. They show up, you get in, you get at your destination, you get out. Just take that from down to one point. Some place somewhere has a big physics machine that opens a portal from you to your destination, and maybe you just step across. But they don't count for ambient and environmental differences, because that would spoil the whole movie magic thing. Although someday I'd like to see them use a sling ring to open a portal underwater, and then put out a fire or something, flood something, use it against a bad guy. But I have seen these. These are actually real world examples of what happens when you don't take into account differential pressures. So you've probably seen historically video of dramatic weather changes across the Great Plains of the United States, when you'll have very cold morning followed by a very hot afternoon, and the wind that comes through as a result of that can be, gale force winds that just come through and they're done. It's equalizing the pressure differential between hot air and cold air. So that stuff actually exists. And the picture on the lower left is when you have heavy rains and the water inside your storm sewer system becomes too much for it, and it just, where am I going to go? So the manhole covers literally just blow off and water comes gushing up out of the ground at force. So you don't want to be anywhere near that. It'll literally push cars out of the way. And the one on the right is some poor young lady was opening the door to her house, and the air pressure differential was enough to have her hang on for dear life. So you got to think about those things. So maybe you need something like an airlock to equalize the air pressure. And the greatest differentials we're aware of right now are between the surface of the land above sea level and then deep ocean. Because if you go deep ocean, you're going to be squeezing the nitrogen into your bloodstream. And when you come back out, you want to do so slowly, because you don't want the nitrogen foaming in your blood and causing nitrogen narcosis or the bends. So we already are aware that too rapid a change in ambient is not good. So think airlocks. But if you need airlocks, an airlock has a certain capacity, and if you need a lot of that because you've got a lot of people traveling, then maybe travel ports. So instead of it being from anywhere to anywhere, we're kind of back to square one to, okay, everybody arrive at the airport. Now it's a spatial transport port. Everybody wanting to go to a certain destination, arrive here. We'll open a portal to a shared airlock for everybody going to that destination. Close the door, close the port, pressurize or depressurize slowly the chamber, and then open the door to not your actual destination, because not everybody's going to the same destination. It'll be a shared travel port at the other end, and then you go find your Uber or Lyft to get you to your final destination. So much like, when it's this big, making it this big doesn't really solve the problem. It's like, yeah, this is definitely an improvement. Would have massive paradigm shifts in travel, but bringing back the airports isn't a solution to the problem. Well, maybe only initially we need them, because if the big physics machine that's doing this can do it on a massive quantity, small enough ports basis, then you have more airlocks. But do you really need an airlock if you're going to be moving to a position that's like the halfway point? So if you're going from Fort Lauderdale at sea level to Denver Mile High, you probably want a couple of stops. So we'll just, create a port from Fort Lauderdale to something that's 1,000 feet above sea level. And you can easily step across that, pop your ears, and you're done. And then you go through another port and you go another 1,000. and eventually you get to the 5,000-foot mile-high city. No airlock needed. So maybe there is some ports you hop through. Gets rid of the airlock, gets rid of the bottleneck. You don't want airports anymore because mega congestion, like Southwest Airlines or weather delays. You don't want to, we thought we solved the problem. No, you just move, shove the problem down the road a ways. But yeah. So who would be willing to do this if there were large travel ports? I don't know. The same guys called airlines that do airports and convince, regional taxpayer money to be spent to build airports. They could be spending the same amounts of money on spatial ports. But a spatial port doesn't need runways and taxiways, and there's no pollution from them. So you could build them anywhere you had a lot of land. And since you're going from anywhere to anywhere, things like the regional jet port that failed in the Everglades would have no problem. It's a large chunk of open land that doesn't cost much, and you just put down a spatial transportation port. So they could be anywhere. Cheap land. Doesn't have to literally be an airport or a seaport or a train station. Can be anywhere. So what would be the paradigm shifts? It goes from the large, complex, big money down to the simple stuff. So as soon as we get it to the personal level, people would become less social. I sometimes have to go to the grocery store to pick up stuff and have to interact with other people, mostly just the other people in line waiting to check out, the cashier, the bagger, those kind of things. Maybe the store manager if I'm looking for something, but I interact with people. The moment I can just open a port from me to the pickup spot at the grocery store, I'll just grab my groceries and bring them in. So less social. If I don't have to go to a train station, a bus station, an airport, or a seaport, I'm going to be interacting less with people. And even all the indirect suppliers of things associated with personal vehicles. Well, I don't need a car anymore. I don't need a pickup truck anymore. What about all the manufacturers, the parts suppliers, the new and used car sales lots, gas stations, service stations, car insurance? Well, the good news is the accidental deaths and hospitalizations will go down, so hospitals will have less business. Stores and businesses along those transit routes, they're like, you got to stop here because this is the point in the road where we put the rest up. Those are likely to go out of business. If you evacuate major highways, railways, airports, they could be declining in business. And if you're not using a road, why are you maintaining it? So for the people that are left on the roads, pothole city, not maintained. Overpasses could crumble. We already have bridges that crumble, and those are supposed to be maintained. We could find that defunct shopping malls, since they're easier to get to, come back on the rise because it's the last bastion of social interaction. So if the transport can be for other than people, deliveries of food and products, when I want something from Amazon, have them deliver it to my front porch. I don't trust them to deliver it inside my house. Can't open a portal inside my house? No, I don't want you here. What about simple stuff? Okay, a construction company that wants to go do some work might have to go rent a scissors lift to get up to the height to install some windows or something. But if you can just open a portal from the ground to where the windows are, you can not have to get on the scissors lift to install the windows, which is going to be cheaper and faster. Think about the scissors lift. You have to load the windows onto the scissors lift, raise it up, install the windows that would fit on the scissors lift because you can't have an infinite load, and then you go back down, you move the scissors lift, put some more windows on it, raise it back up. So, if you could just open a portal and go window, 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 okay, move the location of the portal, window, 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 it's a lot faster. So even if it costs money to open the portal, and the collective amount of money is more than the rental of the scissors lift, the contractor is still saving time and money. So it may look expensive, even if it costs lots of money, but it actually overall costs less money. What about all the little mom and pop motels along the way that I'm tired, I've driven all day. Oh, look, there's a motel. I'll just go in there and pay, rack rate for my room. Highways. Now, this is the weird thing. I actually found images of highways that were very wide with no vehicles on them. How did that happen? Well, they were doing overpass construction. And if you've ever seen that on I-95 or on the Turnpike, when they do overpass construction, there's a section of the road that literally can have no cars on it, no trucks on it. So that's how you get pictures like that. Warehouses would exist, but they could be out in the middle of nowhere and you wouldn't need regional warehouses. You just need, planet-wide massive warehouses. So those robotic models that Amazon and Target and places like that have would just get bigger and would cost less because you don't need regional ones. Okay, so now we've got a computer that can open a portal and we can deliver any size things we want. We can deliver simple packages and meals all the way up to, cargo freight containers. And okay, so we now have control over how big a hole we can open and how many of them we can open. Let's think about what we can do with that. If we can open microscopic to small size stuff, we can now use it for equalizing pressures. We can use it for transferring, observing, injecting. Let's say, hey, there's an asteroid or a comet that's going to hit the Earth. Well, we'll open a portal before it gets here and open another one after it's already gone by and just have it go, boop, never hit us. So that would be a way to save the planet more so than any of these other cockamamie nuclear blow things up, impactors that blow dirt balls apart. Hey, I like that idea. Go spend billions of dollars figuring that out because there's literally an open-ended number of other uses for it. How about volume of transfer? If I can open lots of ports between two places, I can mix stuff. If I want to, I've got a container full of stuff over there, and I've got a container full of stuff over there, and I want to mix them together. I just open a port between those two places and mix them. So I didn't need any transport to deliver the materials between the two. So how many individual things can be transferred per square area? What's the flux of materials? How long can I do this? If you remember on the series Stargate, they can only open a wormhole for 43 minutes or something because movie magic. It became plot lines. So if you can open something permanently, you may find that, why am I making a tunnel through a mountain? I'll just open a port on that side, open a port on that side, and now I've made it where people can freely move between two cities on the other side of mountains. Leave the port open. And if I can do that, why don't I move fluids or gases that way? Who needs a pipeline? So if you're worried about Russia's petroleum pipeline, cut them out of the loop. Get your petroleum from the US and have it delivered directly via portal from the US to Europe. Sometimes these things get simple. What if you want to move things that are, wet to dry, dry to wet, cold to hot, hot to cold? How about this one? There's a forest fire in California. I want to put out the forest fire in one shot. I open millions of small ports inside of a large body of water, fresh water preferably, and I can literally create a giant sprinkler system to put out the forest fire in one shot. Remember, I can adjust the size of ports. I can make any number of them that I want, and it's all under computer control from point to destination. What if I want to invigorate a desert area? I want to take the Sahara and make it bloom. There's a lot of salt in the Sahara. I could actually start by creating it as a salt flat and then, putting in plants that are salt resistant and cool it down. Once I cool it down, then the humidity will actually bring fresh water to it. And now I have no more desert. If I have an area that's too cold, I can warm it up. If I have an area that's too hot, I can cool it down. Of course, we have to worry about those air currents and pressures. How about hurricanes and tornadoes? I could literally say, oh, there's a hurricane forming in the Atlantic. I will open a port in the center of the hurricane to an Arctic location. Not a big port, just enough, and I will deliver enough cold water, enough cold air to dispel the hurricane. Moment. Done. Gone. What about floods and tsunamis? People have often said, why don't we take the excess water we've got flooding through certain areas and deliver it to areas where we don't have enough water? Like, I don't know, a certain hydroelectric dam off the Colorado in the southwestern US, and all of the floods that we have after the wintertime in the north central parts of the US. We'll build a pipeline from Nebraska to California. Through what? Through what major cities? How big a pipeline? How many billions is it going to cost? Well, this solves that problem. So now you can literally, you got some flooding somewhere, you got some place you need the water, open, move the water. As the saying goes, infinite uses. Why don't you spend the billions to figure it out? How about space travel? You want a sample return on Mars? You would have to open a moving port. So you open a port on Earth, obviously taking into account the air pressure and atmospheric differences. Open a port, take your scoop up some dirt, close the port. Here's your sample. A lot simpler, and it costs billions less than sending spacecraft to Mars, having it drop off cylinders that will go back and spend other billions to go pick it up and bring it back. We could, do samples anywhere. We could travel anywhere. We could do large scale manufacturing. So if your manufacturing operation works better in a vacuum or works better in microgravity, build yourself a big plant where there's no air and microgravity. Problem solved. Like I said, you could save billions to cover the cost of developing it once just by what you'd save by improving what you've got. How about straightforward stuff like healthcare? Think about microsurgery, or you need to remove or implant something without incisions. Part of the healing process is, even at the orthoscopic level, all of the incisions and healing and things like that you have to go through. Anything that gets damaged, you can easily go in and repair without severe surgery, without, deep surgeries. How about cardiology? What if you could open a portal inside of vessels and remove plaque? You could save a lot of hearts and eyes doing that. What about ophthalmology? Removing floaters, repairing detached retinas. You could literally, at the molecular level, decompose cataracts. What about those stones? Kidney stones, gallbladder stones, stones in your bile ducts. Just go in and take them out. Dentistry. You could remove a decayed area without creating pocket holes around it to hold in the filling, and just replace the decayed area by taking a piece from a solid chunk of solid zirconia. So dentistry would become far simpler. There's no anesthesia, there's no drills, there's no clamps, there's no it hurts, cold air. There's no injections of things. There's no cold water, it hurts. There's no grinding down of your teeth, no crowns, no root canals, no multiple hours stay in a chair while they do a 4 nerve root canal on you. If you have to have an extraction because something is damaged or rots away, the extraction becomes instantaneous. And replacement with an implant also becomes instantaneous. But you might need to stick some graft material in to, anchor the implant. But, once you realize how to do that with glues rather than grafts, the implant might be instantaneous as well. And you could do it on an individual tooth level. You might find that if you have to deliver pharmaceuticals or radiation, you can deliver it precisely to targets. People might have heard of things called the gamma knife, which is a way of going in and destroying tumors at almost the cellular level. Why don't you just take the tumor out at the cellular level? If you're contaminated by some foreign material, be it bacteria, virus, or cancers, just remove them at the cellular level. And more mundane stuff like assaying and mining. I want to go find some oil. How do I do that? Well, I need ground penetrating radar, or I use X-ray penetrating, or I use ultrasound, or high altitude spectroscopy. And then I got to go to the site, dig a hole in the ground, stick in a probe, get some sample out. Would it be a lot safer, faster, and cheaper if you just said, hey, I think there's some stuff down there. Let's open a port from my lab to some place, 300 feet below the surface and see if in my microscopic sample that I take, is there the right kind of mineral there? Is there oil there? Whatever. No pollution, no disruption of the environment to do sampling. Okay, let's say you find there's stuff there, you want it. You don't need all the other stuff that comes along for the ride. So you don't need to dig a giant tunnel in the ground to get out the gold. You just use spectroscopic analysis and say, I only want to take out the gold or platinum or whatever, and I don't need to take out all the rock that's surrounding it. No tailings, no mining waste. And you want to fill the void? Fill it with stuff you don't need. Fill it with rock that you transport from elsewhere. You want to build a tunnel. You want to level the top of a mountain. There's lots of material you can use to just take it from here, put it there. By the way, no drilling, no blasting, no cut and cover. So even if you wanted coal for whatever reason, you wouldn't have to cut and cover to have a coal mine. Considerably safer, faster, cheaper. Think about big corporations, net profit, return on investment. You don't need any surface equipment, no transports, no pipelines, and no unsightly stuff, no polluting, no expense to do it, and the time it takes to do it. Then we get to the really, really mundane stuff. If you want to paint something, you don't go get yourself a scissors lift and paint it. And you don't even need sprayers or painters. You just have a container full of your painting material and you open millions of tiny pores at the surface of the building and you apply pressure to the paint. And there you go. Paint coated with exactly the level of paint that you want, and it fills all the pores. How about cement and steel transfers to build a building? Well, if you've ever seen the snorkel and how you get liquid cement and rock up to a building that's 50 stories up, it's a process to get the cement up to that level. You don't need that anymore. You just open it from wherever the slurry source is to wherever the floor is and dump it out. You want to put in beams for girders, for overpasses and bridges, assuming you still need roads. Just open it at the factory where you created the pre-stressed beam and deposit the beam. Cleaning windows. Guys don't have to risk their lives to clean windows anymore. You just open the port where the window is, making sure to take into account the air pressure difference in altitude, and you just clean the window, close the port, go to the next window. Imagine if you still had ships and you wanted to take the ship out of the water to paint its hull. Literally, you could transport the ship onto a frame and paint it and send it right back. You don't need all the shipyard stuff that you need. You don't need the locks to do all that stuff. What if you wanted to monitor something? Take the cameras, have them in a centralized facility, and open ports to wherever you wanted to monitor. So if you wanted a monitor that was always 200 feet above the ground, facing at a particular angle, you just leave the port open. Costs you a certain amount of money per month for your port. You want communication. There's a mountain in the way. I want to send radio signals. You open a port, you send the radio signals in, you open a port to destination, radio signals go out. Two-way communication. This one I plucked from sci-fi and comedy. If you want a giant display for a public event, you open a port behind every pixel that you want to have in your display, open millions of pixels to bright sources, and you just lay those out flat in 300 feet above the ground, tilted at a certain angle, rotated at a certain angle, open all those holes, and have the computer control the lights. So you now have a massive display just hanging in the air. And there's nothing to set up, nothing to tear down. You don't have to have 1,000 drones in the sky to do it. And if you had some noteworthy politician who had to speak to a giant audience of people, open a port to a podium and raise the podium up through a port at some place 50 feet off the ground. And now you have a person just sort of standing in midair speaking to a crowd. I'm sure a musical group could do the same thing. Okay, you could use it for defensive mechanisms. Send it somewhere else. So if something is headed your way, open a port in its movement path so close to it that it can't steer out of the way fast enough, and send it elsewhere. So if you have aircrafts, troop trucks, military ships, missiles, even hypersonic ones, high caliber explosive bombs, armed drones, just open a port in their path and send them somewhere else. You don't have to, send them to horrible places. Send them back where they came from. If you could open enough ports and detect them fast enough, you could even take a hail of bullets, open the ports, send the bullets somewhere else. If the thing that's coming at you might actually explode, then you can probably open a port close to the sun and have it just burn up. Send it some, distance from the sun, well closer than Mercury. So as soon as you open the port, it's gone. Now, if you're sending something away that might contain people, like aircraft, troop trucks, things like that, you don't have to send them somewhere harmful. Just send them back where they came from with no damage. If you do it so easily and you defeat their offensive potential so readily, they might think twice about doing it again, or they might try and create your technology. If you yourself are in danger, open a port, be elsewhere. So if it's a lot of things and you can't control a lot of things, you just be elsewhere. How about orbiting and deorbiting stuff? If you really want to put something in space at, let's say, L2, you don't need a giant rocket. You just need a chamber where you've got your spacecraft. You open a port, moving it in space-time relative to L2, push the spacecraft across, close it. Hey, spacecraft is now in orbit. Far less cost. No rockets. You don't need to build a spacecraft sturdy enough that it can, take a 9G launch with solid boosters. So if you really wanted to put something in orbit, find the orbital path you want to put it in. Get yourself a vacuum chamber, open the port, open a moving destination at the speed you want, and just spring eject it into the destination, close both ports, and now the vehicle's in orbit. You want to deorbit something? You want to get rid of some debris in space? Just open a port in front of it, have it fly in. If you want to burn it up, you can actually open it the other direction. So if it's going in this direction and you want to burn it up, open a port in this direction into the denser part of the Earth's atmosphere. It'll burn up rather quickly. So if you can do this, why do you need rockets? Just put stuff in space when you need it in space and recover it when you need to recover it. You don't need to burn it up. And as I mentioned earlier, saving the Earth. If something's coming at us, locate it, open a port, send it somewhere else. If it's a comet, send it back out to the Oort cloud. If it's a short duration comet that's probably going to wind up burning up in the sun anyway, send it in the sun. If it's really foul space junk, send it to the sun. If it's a sufficiently large object, just move it past the Earth. I wouldn't suggest moving the Earth, but move the object past the Earth. So no more impacts. And you don't have to blow up or nuke anything, and you don't have to worry about rubble pile asteroids and such. Just solves the problem. So what about saving Earth from itself? If you're like myself, or maybe Helen, been doing a lot of watching videos involving the Younger Dryas and how Earth changed at the end of the Younger Dryas. And part of it was massive amounts of water rapidly coming over land, like super tsunamis kinds of stuff. And it's like anything coming at you that you don't want at you. Open it to someplace else and reverse the direction on it and send it somewhere else. So if you've got water coming at you, open a portal that's 90 degrees to that out in the middle of the ocean and have the water just fan down through millions of ports and dissipate. If it's a mega volcano or volcano kind of thing, send it back into itself, or send it someplace that could really use a lot of land. If you've ever looked at the channeled scablands in Washington State, it's just giant open areas where water came through and carved out, hundreds of feet of just channel, many, many miles wide. So if you've got a volcano and you want to create some nice flat land at level, just dump the volcano, molten rock into there and have it cool down. Look at all the land you've got. If you've got an island, you want to make some more island, as they do in Hawaii, the volcanic flow goes off into the sea, and then after it cools down, the volcano changes the path elsewhere. Look, we've got some new land. Build a park, build a housing subdivision. Yeah. If it's something that's very high speed, like a pyroclastic flow, send it ahead of itself or send it out somewhere else. And as I've mentioned, if it's a tsunami, send it elsewhere to dissipate itself. If it's a mega flood, like something happens and we get a mega glacier release, open a port in front of it, open multiple destinations, fan it out, distribute it, change some deserts into grasslands. If it's an iceberg, it's freshwater. No more civilization-threatening natural disasters. Here's a thought. If this is advanced technology, we may not be the first to come up with it. If you look at UFOs or UAPs or whatever they want to call them these days, and you look at the stuff from the 40s, and then you look at the stuff that's out there today, it looks like their technology might have advanced several generations. Well, if they've done that and their civilization is on a planet that's orbiting, let's say, an orange star, as opposed to as we call it, a yellow star, if they have a million, several million, up to 1 billion years head start on us, then this could be old hat technology for them. So open a port from their home planet, open a port in movement on Earth, arrive. No spaceships needed, no UFOs, no UAPs. And if they happen to look like us, dress like us, they know our spoken languages, they might fit right in. So where would they be opening the ports from? Someplace you wouldn't see. They could open a tiny port for a camera or audio to check to see if anyone is around. And if they're not, open, arrive, close. They could do the same thing on, destination if they want to go home from Earth. Same thing. So if they can do that, how would you know they arrived, and how would you know they departed? You wouldn't. And if you want to monitor an area, let's say if you've seen UFOs looking at, military industrial complexes, and oh, look, there's aliens monitoring our nukes. And why would you need that if you have this capability? Just open a very tiny port 5,000 feet above the military base, and you have 24/7 video coverage of it. And if you can do that, by the way, if I can get from point A to point Z at the same time, I don't have to worry about, the amount of time it takes to travel between 2 points in space. So I could literally travel from this time to this time there. There's no, propagation delay at the speed of light. You haven't broken the speed of light. You haven't moved faster than the speed of light. You've just joined 2 points in space-time, and speed of light becomes irrelevant. So if you can do that, maybe that's your answer to the Fermi paradox is they're already here, you can't tell and don't know. Okay, that's all the good. What about the bad? And the bad can get really bad. So let's hope that pacifists come up with this spatial transportation, because in the wrong hands, it can be abused to horrific ends. You probably want to control proliferation of this technology far more than atomic weapons, chemical weapons, biological weapons. Probably want a tighter rein on this stuff than anything else. You want to eliminate your opposition? Let's start with political rivals. You can do that. You open a port from, somewhere in space to wherever the bathroom is of your political rival, where they're in the bathroom, and they just got gone. Don't know what happened to them. If you want to do it to all the leaders of an opposition government, you can do the same thing. So if I wanted to do something more subtle, I can open up a microscopic, short-lived port within a military or political enemy. I could open their heart to vacuum, drain out just enough blood directly from the heart so that it doesn't pump, and you get instant insanguination, loss enough blood that they just go off like a light switch. I could do the same thing to their spinal connection. I could go in and remove a single cell layer of their spinal cord as it enters their brainstem and switch them off like a light. And when I close the port, the brainstem would join back up at the cellular level, and you never even knew it happened. I could inject arterial plaque, have them have a heart attack. I could inject cancerous tissues. Yeah, normally that would take 5 years for them to die from it, but they died from it in 6 weeks. No trace. Or I could do really nasty stuff. If you remember Star Trek: The Next Generation, they had this thing called the crystalline entity that would just create radiation beams and vaporize all the stuff in whatever path it wanted. So if you wanted to do something like that, just open a radiation beam from Jupiter to wherever your opposition is. And much like we were thinking of neutron bombs, this would be even cleaner than a neutron bomb because there's no explosion. You just irradiate your opposition, wait for the basic radiation to decay. It might have only be days because it's not actually, long-lived radiation. It's more like just beam of ionizing radiation, and go back in and take over. And if you open the port underground to a cave or a bunker, there would be no place you could go. Now, the problem is people are idiots, and somebody who didn't know any better could accidentally open a port to the sun, somewhere inside the sun, and as the Earth rotates, what's coming through that port would literally obliterate the atmosphere and surface of the Earth. So if you left it open for one day, Earth's no longer habitable. So the inappropriate use or the misuse of this technology could aptly be described as a great filter. They were there, their technology got to a certain point, and then all of a sudden they're gone. Well, you don't want to think about in the wrong hands too much, because it's the stuff of nightmares. And I did actually find a reference to ancient Indian texts. India, not American Indian, but India. Dharma, or holy duty, is contrary to a discussion between Arjuna and Lord Krishna, or Vishnu. They actually had a conversation trying to decide whether weapons as powerful as nuclear weapons should ever be used for destructive purposes. And the human said, no, never. But then Vishnu said, I don't know, sometimes you got to use them. And so if you look in the ancient Vedic text, you'll find that sometimes they use them. And there are places on Earth where we find the remnants of cities and we find radioactivity, but we don't find like uranium caves, mines underground. It's just, well, that city happens to be radioactive. It could be ancient battles that somebody came out on the short end of the stick. But I'm not sure that you could even trust governments today, because after all, we used nukes twice. If you study the history of the fabrication of nuclear weapons in the early days, we didn't use 2 nukes because we only had 2 nukes. We used 2 nukes. There was a 3rd nuke that had already been delivered and was being considered for use. If you look at the history of the US's nuclear weapons deployments in Japan, Hiroshima came first. There was a different city than Nagasaki, but since the weather was bad, we rerouted to Nagasaki as a secondary site. Japan did not initially surrender unconditionally after Nagasaki. It took the Russian invasion of troops into the northern parts of Japanese-occupied China before the Japanese unconditionally surrendered. But we were already with another nuclear weapon to deliver a nuke to that 3rd city that we skipped past the first go round. And we actually had 2 more nukes being built in process. So we actually had 5 nukes that we could have used had Japan not surrendered. And they didn't surrender because of the nukes. They surrendered because of a massive troop invasion by Russia into Japanese-occupied China. Technology can be used accidentally or on purpose. And if you have significant enough technology, that could be a great filter. So they were there and then they were gone. I don't know what happened. Is this too tempting a technology? Well, yeah, I think so. I'm just a guy that put something together in the course of 2 weeks and said, what if? If I'm just spitballing it, imagine organizations that have thought more seriously about this stuff. The U.S. Department of Defense has an organization called the Defense Advanced Research Projects Agency, or DARPA. This is the group that says, what if? And the military goes, yeah, we'd like one of those. Go make it happen. Or improve this because it's not quite good enough. So DARPA goes out and spends black project money, sometimes to the tune of billions, to go make it happen. This is the solution creation arm of the CIA, the DIA, the NSA, and the Department of Defense. So you can imagine they might want to spend money to do this stuff, and there might be corporations that wouldn't mind having the patents on this stuff to monopolize the capability. Imagine how many billions they've spent in quantum computing, and that's just to dominate a potentially multi-trillion-dollar market. Imagine if you could dominate a planet, all industries of it. You think DARPA would spend money on that? Yeah, lots of black project money. So, are we doing this stuff? There once was a Dr. Ning Li. Dr. Ning Li is somebody that it's a rabbit hole that if you've got lots of time, you might want to go look at it. But other than that, just listen. There was a researcher at the University of Alabama, Huntsville. If you think of Huntsville, yes, is close to where NASA developed rockets back in the day. So in 1991, Dr. Ning Li was a Chinese national, but in the US, working at the University of Alabama, and she was researching gravitational effects of near room temperature superconductors. Everyone's probably aware that if you have a superconducting magnet and you put it above near zero temperature materials, that the magnet will hover above the superconductor and will actually stay within the guidelines of the magnetic field induced in the superconductor. So she was looking at that stuff going, what if we can use this for other things? And can I get to near room superconductors? Do I need to really chill it down to 0 Kelvin? And okay, she did some things. And in 1997, she was one of the authors of a peer-reviewed research and the American Physical Society's Physical Review B. It's peer-reviewed. It's one of their journals, and they put that in one of the journals. Popular Mechanics picked up on this in the year 2000, and they did not even give it a cover article. They buried it and called it Taming Gravity. It was far-fetched. It was an article by a reporter named Jim Wilson. But apparently there was enough behind it that in 2001, the U.S. Department of Defense gave Dr. Li $448,000 in a grant. She promptly left academia and started a company called AC Gravity LLC. And that corporation still exists, but is pretty much inactive. She dropped out of contact in 2003. She's like, I don't know what happened to her. She's gone. They just thought that she might be working on some deep black projects, but apparently she went back to her native country, China, and she reportedly died in 2021. There were rumors that she went back to China, where she was given whatever funding she needed to advance her research in gravity manipulation. In Austin, Texas today, there is a company called, they just flipped the words around, Gravity AC LLC, and it's an active corporation. Don't know what they're doing, but curious. And if you want to watch the video regarding Dr. Li, there's a YouTube link there. And it turns out that a lot of the stuff that she was working on got patented by the U.S. Department of Defense, specifically by the U.S. Navy, under the, we don't know if it's a real guy or not, name Salvatore Pike. There's a lot of patents involving gravity manipulation that are under the auspices of the U.S. Department of Defense, U.S. Navy. Who knows if they actually build something, but if it's a patent owned by the Navy, then commercial corporations are not going to be developing products for it unless they have approval from the U.S. Department of Defense, because the U.S. government owns a patent. Your tax dollars made it happen. Commercial entities aren't allowed to just go, unscrupulously go off and do that on their own without approval from the DoD. So that's one way of controlling technology. So if this stuff really existed, why wouldn't you do it? If vast fortunes can be made from fusion power generation, and we know it's really, really hard, and it's taken decades, and we've spent billions at multiple sites all over the planet to try and conquer fusion electrical power generation. Why do you want to bet some people aren't off spending black money projects on spatial transportation? I know it's hard. I know it might take decades to figure it out. But once you could, even if it's on a small scale, if you remember the H.G. Wells book on time travel, the example they tried was a little model time machine that they put a bent cigar in and then sent it downstream to the exact same physical place in the future. And lo and behold, it showed up a year later. And they went, oh, I guess it works. Well, if all you did was open a port from one side of a room to another, just to prove you could do it, and in between the two was, let's say, I don't know, a steel reinforced concrete wall, and you could prove to the DOD that you could get inside of a building without blowing a hole through the wall, without knocking down the wall with a tank. You think the military would find a use for that? Yeah, I think they would. And then if you could use it to prevent natural disasters, your military could survive. You would have superiority. You had open-ended revenue streams for governments and corporations. Yeah, I think there'd be some money in that. Far more money than fusion power. Far more money than quantum computing or particle accelerators. So what would be some of the uses you could see? There was a Star Trek original series episode called A Taste of Armageddon, where the aliens, in order to battle each other, were materializing antimatter bombs above their targets in a war. Well, if you could open a port and you could push across a nuclear device, close the port, and then detonate it, yeah, that'd be a great way to win a very destructive war very quickly. And I like this one. This was kind of the same sort of thing. The series Stargate Atlantis. They had an episode called The Siege. It was part 3. It was a 3-parter episode where they used the Asgard beaming technology to take a nuke and beam it inside of a wraith ship in order to destroy the wraith ship. Couldn't get through their shields except by way of beaming technology. But that was like, matter transport, and everybody knows that stuff had never worked. So if, let's say, we didn't have this capability and China and Russia suddenly gave hints that they might have this capability first, do you think it would be worse for the US than it was for Russia to have Sputnik first? Or worse than if, let's say, Germany in World War II was the first to put nukes on V-2 rockets? What would you regard your government as if we were not pursuing the forefront of this technology? I would simply declare that government as inept. I very much hope they're spending however many billions it costs to really do serious research on this stuff, even if it's a black project for 100 years to come. As long as we have it, patent it under the auspices of the DOD, and it's more closely controlled than the proliferation of nuclear weapons, I'd be okay. Okay, this is another one of those episodes of connecting the dots. So, lasers. Who knew what lasers could be used for back in the day when they were popping holes through Gillette razor blades? They're using them for everything these days. Maybe we'll discover that everyone else in the universe, after they get through their flying saucer phase, they develop spatial transportation and abandon all those other forms of transportation. Ships? Who needs ships? So they have the UFOs, and then they don't need UFOs. So, as I said, if they look, talk, and behave like us, and you can't tell whether they're here or not when they arrive and when they depart, then sounds like a good error to the Fermi paradox. Of course, on the other hand, if they develop the technology and either do dumb things with it or misappropriate it, misuse it evilly, then that could be your great filter, in which case, once again, you have a good answer to the Fermi paradox. So once we can literally go anywhere we want to go, and we don't have to worry about time dilation or propagation issues, no Newtonian physics issues, and we realize that we're seriously not alone in the universe, then maybe a lot of bad science and false beliefs that we refer to as contemporary mythologies might fall by the wayside, or all the people that believe about those mythologies fall into the enlarged category of flat earthers or moon landing deniers. Things get better, much better. So that's just me connecting the dots. So I connected the dots further. It's going to go a little further. So I said, okay, so if I can open a port anywhere, and I can open lots of ports, and I can do it under computer control, what would stop me from opening ports in other materials? And I found out that there's this ability to separate molecules. There's a specific distance that if you can push two molecules apart, and it's only like a nanometer, a billionth of a meter, that molecules will literally separate without any discharge of energy, any explosive force, nothing will combust. The material will just separate. So if we can create things like that, then we can obviously mine stuff. We can remove stuff that needs to be transported away. We can do any 3D shape we want. So we refer to subtractive manufacturing as the computer-controlled removal of stuff, cutting and drilling and routing and tapping and shaping to make things smooth. We bend stuff using things called brakes. Well, you wouldn't need that anymore. You just remove the parts you don't want. How about composition? We could mix stuff. We could make stuff as hard as you want. We could remove material along molecular lines. It would result in infinitely smooth looking polished stuff. We could make reflective surfaces. Imagine if you had a block of alumina and you removed a piece of the alumina at the molecular level. That would be a smoother surface than any polished mirror you could ever make, because it would be finer than any grit you could ever create. You can make incredibly tight corners with no rounding. You can make 90-degree corners inside of hard materials. Does any of this sound familiar? I'm not talking about doing anything massive here. All I want to do is have the ability to go in and break apart what is known as the van der Waals forces. All I need to do is take molecules and separate them out by about a billionth of a meter. So if I can create a line of molecules and push them apart by a little less than a billionth of a meter, this part of the material would just fall away and the rest of the material would be there, having a perfectly polished surface. Now, I don't need to, break apart the actual molecules into elements. I don't need to take water and separate out the hydrogen and oxygen. I just need to separate out the water molecules. You want to know how easy that is? Take your hand, stick it in a bucket of water. You're separating molecules, not atoms, not elements, just molecules. How much energy does it take to do that? Relatively little. Just don't try it with like granite. But popping a pin on a balloon, it's separating the molecules. You're not separating atoms. You're not separating elements. You're just separating the molecules. When there's pressure on the inside, it takes very little to push at the point of the pin molecules far enough apart for the molecules to actually separate. At certain distances, they go from being attractive to being repulsive. So that's all the material, that's all the energy I need. So we already know that there's a Nobel Prize for using light to push viruses and bacteria around in X-ray in electron microscopes. And it takes very little energy to do that. So if I could use a 0.5 nanometer high flux gamma burst, and I can deliver that inside of a material, wouldn't be an explosion. It would just be suddenly under computer control of the surface, I cleave the material because the molecules will separate. And when they get to a certain degree of separation, there's nothing holding them together anymore. They just separate. They fold apart. So not looking for the big energy stuff. Not looking to break, water into hydrogen and oxygen. I'm not looking to split atoms into protons, neutrons, and electrons. And I'm not looking to break protons into quarks. Very little energy here. Here's what that's useful for. I found this to be something rather curious. The ability for us to have 3D CAD software to create simultaneous curves intersecting over a surface is something called non-uniform rational B-splines. The acronym is NURBS. NURBS were not even invented until 1993 in 3D CAD software. So the ability for us to have, routing and milling machines and such to basically carve a person's face into metal, smooth curves without having lines in it, did not exist until after 1993. So, we've been doing metal cutting and carving and wood and things like that. We've had routers, and I think it was in the 1940s they first started looking at the concept of CAD even before they had the computers that could do it. And it wasn't until probably the late 60s that we had the first CAD machines. Very big computers, but computer-controlled milling. Nowadays, we take it for granted. For a couple $100, you can go buy yourself a 3D printer. And that's a CAD software saying, I want to create this shape. Okay, to create this shape, you just melt this plastic and move the head around and you got the shape. Or stereolithography, or SLA. I got a vat of resin. I've got a little display on the bottom. I've got UV lighting, and I just I caused the UV light to harden the resin one thin layer at a time at up to 8K pixels resolution, and up out of the vat of resin comes a solid object, and you can't even see the lines in it. If I can separate out molecules in stone, it wouldn't matter how hard the stone was. I could carve any shape regardless of complexity, and not only could I carve complex shapes, I could carve it with high precision, no mistakes. And if I needed a lot of them, I could, under computer control, carve them out with high quantity repeatability. So people will probably note that if I look in ancient Egypt, there's a lot of these very large statues that have very similar complex shapes that are rather uniform. Doesn't look like a lot of chisel marks on them. But there are some where a pillar is like half carved out of the ground. And they say it sort of gave up on it. What if they found that there was a vein running through the giant pillar that they didn't initially see? And if they actually did carve it up, it would have cracked. Or they found that they were doing a little change in the software algorithms, and no, they kind of got that one wrong. You just leave it there. So a lot of the stuff where they see mill marks or tool, that may have been early generation stuff before they got the CNC from carving into spatial transport of molecules. Now, when you look at these things up close, you'll see what I'm talking about. So here are examples of things where we're trying to figure out how this stuff got done. Some of the ones I didn't know was, if you look at the Great Pyramids at Giza in Egypt, everybody likes to look at the pyramids. If you're ever there, look down at the stone walkways around the base of the pyramids. There are multiple ton blocks made out of granite, not sandstone, they're white granite. And the blocks fit together so tightly that you can't insert a piece of paper. And this is the walkway. Everybody's looking up at the big buildings. What about the walkway right under your feet? Yeah, people didn't build those unless they were done a long time ago. The places where temples were built out of in place, as it's called, in situ stone, where you can't make a mistake because there's no go over and do it over again. So if you could remove all the stone under computer control, you could carve up places like this pretty quickly and with no mistakes, unless you had a software algorithm problem. If you talk about the H blocks in South America and the troughs and very small holes cut with high reliability and repeatability, yeah, if you just remove the material at a molecular layer, you wouldn't leave any tool marks. There's no like drill edges or plasma melts or laser ripples. It's just material's gone. But if you had access to separating molecules and you had NURB technology in your 3D CAD software, you could do things like this and do it relatively easily. What would be the dead giveaway? People talk about about the sarcophagus inside the one of the temples in Egypt as the sarcophagus smoothness of surface and flatness and 90-degree precision of angles don't match the temples that they're sitting inside. And in fact, some of the hallways are smaller than the one-piece box of the material that's sitting inside the chamber. How'd they get it in there? Well, let's see. If you have a block of diorite, very hard granite, and you transport the block out of where it's sitting in situ, you would have, a hole in the ground where the block came from. Look, that's where they mined it from. And then you take the block and you transport it inside some place. And then you transport the inner container out of the outer layer. And now you have very precise, smooth surfaces, very sharp right angles. And the content that was inside the box you cannot find. There's no debris left over, which there's no debris left in these temples. And people say, oh, they picked it all up and moved it out of there. If you carve something that big out of granite, there's apt to be a debris pile elsewhere, and they don't find the debris piles. But if you were to remove material from these very hard surfaces, the thing that would be different from if you ground it smooth, when you grind it, and there happens to be natural pores in the stone, grinding would cause the edges of the surface of the pores to be rounded, because your grinding material would get inside the pores and would wear down the edges of the pores. If you were removing material at the molecular level, all of the edges of the pores would be perfectly sharp. They would be molecular sharp, just like the surface is molecular smooth. So I was trying to find some pictures where that would actually be the case. And yeah, in those boxes in the tombs in Egypt, you can actually see that. You can actually see where the natural stone has what would be gas bubbles in the volcanic material before it's solidified into stone, and the edges of the holes are all sharp. They're not worn down. When you look at, this is from one of the stones at Pumapunku, you can see all the holes where there were air bubbles in the stone, and they're not worn down. They're still sharp along the edges of the holes. Now, in this picture on the bottom, where you see the chip out of the corner of the hole, there's a hole to the right of it. There's no chips out of it. But if you look at the surface that's very flat and smooth, the surface has all sorts of little holes in it. And they say that's from weather erosion. If that was the case, then this little round hole here would not be so precisely sharp-edged round on the top of the hole. It would be smooth, but the surface is perfectly flat, but the hole is sharp-edged round. So yeah, if you just remove things at the molecular level, exhibits A, B, C, D, if you want a face carved out of actually black granite, then look at the smoothness of this. There's almost an imperfection on the person's face on this, what you would see as the right side of his face, the left side of the area that I've indicated here. And you can see the smoothness of the surface. These are B-splines, where you have the curve of his upper cheek going from below his eye to down lower on his cheek, and then curving up across the curve adjacent to his nose. Those are multiple B-splines on the surface. Remember, 1993 was when we came up with NURBS that would give us the ability to do that in CAD software. So let's talk about future presentations. I was looking at, what would I be talking about in the future? The Nancy Grace Roman Infrared Space Telescope that's going to be put at Lagrange point L2, different orbit than the other stuff that's already there. That's not launching until 2026, so plenty of time to do that. I was fascinated at the statement of fact that global moratoriums do work. So if you remember, we had this big thing about chlorofluorocarbons destroying the ozone layer above Antarctica. Well, it turns out that the ozone layer above the Antarctic is actually healing. It's shrinking because we had a global moratorium on CFCs. How many people are aware that there's another kind of chemical compound similar to CFCs that was not quite as bad because it wasn't being used as abundantly, but the moratorium is actually being adjusted to also remove those called HCFCs, hydrochlorofluorocarbons. Those are going to be globally banned in the next few years. When you ban those, we're going to have to come up with new technologies to do refrigeration. Hey, you know that guy that goes through your neighborhood and says, hey, you got to get rid of your air conditioning unit. You need one that doesn't use CFCs. For only $5,000, I can replace your air conditioning unit. I won't even need to come inside your house. Just sign here. And people go, I'm afraid, I'm very afraid. I have an illegal air conditioning unit. Yes, here's my money. Yeah, well, the next generation of that is, instead of CFCs, it's the scam is going to be called HCFCs. And there are companies working on the technology to get rid of that stuff. If you've ever heard of a heat pump, an advanced, more efficient form of those is the solution to do that, because it won't be using CFCs or HCFCs as refrigerants. It might be using ammonia. So just switch your chemistry around and get the same thing. But the ozone hole is no longer of critical concern, but it's still there, and we still want to make it smaller. You know, hemorrhoids, we're not down to here. So you're going to see the global moratorium add HCFCs in the not too distant future. I had thought about doing something on the younger Dryas, but there's a lot of YouTube videos out there about that. But I could also do on, hey, do you know how old the pyramids are? They're a lot older than you think they are. Well, you can carbon date things that are made by animals. You know, biologic stuff you can carbon date easily. Stone, a lot harder to carbon date because no organic materials in them. There is this egg called the Namibian egg. It's actually an ostrich egg. There's nothing inside of it. It's hollowed out, but it's a antique artifact. And they carbon dated that at thousands of years older than the pyramids. Now, carved into this egg in the upper right-hand corner here is 3 triangular things that have steps on them, kind of like a poor man's version of the 3 pyramids. But how can that be? It's thousands of years older than what we're taught in school is the age of the pyramids. How can it be? Maybe the pyramids are older than we thought. And by the way, what the hell is this decoration that's up on top of the egg? I see 3 rings of water and 2 rings of land. Sound familiar? Atlantis, folks. Now, what is this thing off to the right of the pyramids? Could it be the Nile River? So, yeah, I can get into a very deep rabbit hole in that one. Or I could talk about the CIA declassified The Adam and Eve Story by an author named John Thomas from 1966. Turns out he was a researcher, and they confiscated a lot of the stuff that he had. And this book that he had written just happened to be one of the things that they confiscated. So no bad on the CIA's part there. The problem was when they declassified all of his materials out of the total number of pages that was purportedly in the book, they blacked out all but 60 pages of it. So it's really nothing to see here. What about all the blacked out pages? Can we have those back? Somebody said, well, since they're entire pages that are blacked out, there wasn't really blacked out pages. It was, in chapters, when you have this page left intentionally blank, when you go to you want all the starts of new chapters to be on right-hand side pages. That's nothing to see here. But he also discussed this thing called the lost Pacific continent of Mu. Now, we've already realized that there was once a giant landmass out in the Indian Ocean, and we've declared that to be the lost continent, and we've given it a name. What if there was more than one lost continent, and when the Younger Dryas end flooded things by several hundred feet of ocean, it took with it 2 continents, not just one? If you go on Google Earth and you look in the Central South Pacific and you look at the imagery of the bottom of the ocean around all of the islands of the Pacific, there's a huge landmass connecting all of the islands of the Pacific, but the depths get down to over 1,000 feet in some places. But it's just weird that if there was a landmass there, and if it was thousands of years ago, those land masses would be connected, and you would find that Fuji, the Hawaiian Islands, and Easter Island would all have been above sea level. And if they're above sea level, it's not too hard to, travel to those places. So a lot of they went on Kon-Tiki using primitive sailing ships, and they were guided by the stars. Like, it's a lot easier just to walk over land. And the southeastern corner of that landmass is where Easter Island is. Weird stuff. Or maybe I'll do something that I've seen on YouTube just for the sheer pleasure of hornet stirring, stir the hornet's nest. Or maybe we'll get back to fundamentals of physics, which I think we probably will. So next week, we're going to talk about photons and their properties. And in conclusion of this series, yep, I saw problems and I said, is there some way we can apply technology to solve these problems? There's too many industries making good money off of the shortcomings. Spatial transportation, to me, is simply a lack of vision. I think there is significant research being done on it. And we do want to make sure that nobody has inadvertent or malicious use of it. And there would be a lot of paradigm shifts. But we spend how many billions of dollars widening highways every year? Maybe there's something else we could be doing. Whoever gets on the ground floor be it FedEx or American Express or Federal Express or Amazon or UPS or somebody, whoever gets this first for transportation purposes, will have a lot of money on their hands. So that's it. And some links, including, I had to include the Slingy. So the very last link is on the Marvel Sling Ring. There's actually a discussion on the Sling Ring and what it does and, stuff like that. So. Hey, I still have an audience. It's 12:40 and I still have an audience. Wow.
Well done. Lots of research.
Yeah, like I said, it took a few weeks to pull it all together, and I was finding stuff right up until this weekend. I did not know that. So I had to include that stuff.
Wow.
Helen bothered to count the number of lanes in that really wide toll booth path. 46 lanes.
46. Well, that's only 23 going each direction.
No, that was 46 lanes all in one direction.
Oh, no.
Yeah, that was the exit for expressway.
Oh, no.
Everybody had to pay their toll. Everyone's got my email address. Should you want us to talk about a different topic, as Eileen has sent me information about, that's how I found out about the ozone hole stuff. So I'll research it. It may not wind up being a presentation, but it might be a news item, or it might just be a couple of bullets in a presentation. But yeah, I do look at the stuff. I like my members.
Oh, I missed what you said next week is going to be about.
Photons.
Photons. Okay.
Yes, understanding how photons are created, how photons are destroyed, the properties of photons, and some of the things that we've learned in the last 10 years about what photons can do, what all that means and why all that works, and getting down to the ultimate thing. Everything that we measure electronically, we measure in electrons.
Yes. Yeah.
You can't actually measure photons. You measure electrons. Well, how do you get to photons to become electrons? Hey, Einstein had a good solution. Why don't we take the electrons, have them hit material? Why don't we take the photons, have them hit material, create electrons, and then we'll just count up the electrons as voltage. There you go. Analog to digital conversion. And when it's really, really weak, how do we get that to be a large enough signal we can actually measure it? Photomultiplier tubes. So we'll get into that stuff next week.
Sounds like fun.
Okay, we're past pumpkin time. So any other comments before we end recording and close for tonight?
My internet failed. That's why I had to go off and come back again.
Oh, that never bothers me. I just have to make sure that when I hear the sound that I'll go and hit it to let somebody back in. I'm still trying to keep out the riffraff. I never take a look at the log and see people that I don't know that have logged in, because if somebody shares the email, every week there's a new code number for connecting into the Zoom session. So if somebody happens to share the email, they could try to log in tonight. But if they don't share next week's email, they can't try and log in next week. Okay. Anything else before we close?
Thank you.
You're very welcome.
Thanks.
Okay. All right. Good night, everyone.
Good night.
Good night.
Bye-bye.
Happy New Year.
That's it.